Dear students, this is the last leg of the lecture where we are going to develop a very simple web server that is going to serve a bunch of HTML pages, and we are going to see it in action by trying to access this web page via browser. Right. So I think in the last class we started the discussion with this topic, and so basically we are going to, this is also TCP client and server communication, where the server is going to be written by us, that is going to be our TCP server, which is eventually going to be called as a web server, and the browser is going to be the client, and the browser is going to request the web page, and this is going to be served by the web server and rendered in the web browser. Right. So this is also a TCP client server program, as you will see very soon. We'll try to develop that. So before that, let me show you what we are trying to develop. So as you can see, we have this index.html, right? And let us see what it has. We just click on the HTML page, right? So as you can see, there is an image, and this has a form, and you can like write some text here, right? And you can submit this text. Nothing happens because there is no backend that is running, right? So we need to write a browser that can serve this web page. Okay. So this is simply an HTML rendering that is being done in the browser. There's no web server per se that is delivering this web page, right? So we have a local copy. So we are just clicking on the HTML file, and it shows me the content, right? And we also have a images folder where we store this image, right? There is this name.jpg and there is a 404.jpg. These are status code, as all of you know that if a particular resource is not found, this is typically redirected to this 404 status code page, which may have a dedicated page. So you have something that looks like this: 404 not found, the requested resource could not be found, or the requested page could not be found. And we also, let me go and show the code of this index.html. So as you can see, there is some very simple HTML rendering that your browser does, and then there is a JavaScript code which takes the, if you remember, there is this form where you are supposed to enter some text, and if you submit the text, we do some very simple processing on the text, right? So this is a JavaScript that is going to run here, and here what we are simply doing is, I think we are trying to find out the number of characters or words in the text. Okay, so we will see those things, right? In the implementation of the server, whenever there is a message that is submitted from the browser form, we are going to do some simple text parsing. Okay, and that is going to be done by the server. Okay, so here what we are simply doing is we are taking the message. Here there is a small thing that you need to kind of uh, keep in mind, because that's how the web page has been designed, and we are going to do the parsing accordingly. So the message value, right, whenever you are trying to enter a text, the message value is going to be first of all sent by a post request. So there is a get request. You may have studied already these things in the in your course, in your curriculum, that we are going to send out this data via post request, and the message is going to be embedded within these four special characters. There is a percentage star star percentage and percentage star star percentage. This is simply I made up a pattern, and this pattern is going to serve as a delimiter for these messages. Okay, so I can simply extract my message from the post request in the server, and then do whatever processing we need to do and respond back, right? So this is something that, as you can see, there is a response.text which is going to come from the server, and we display that text in the in the browsers, right, wherever the rendering is happening. Okay, so what we will do now is to develop a very simple web server, and this web server is going to serve this set of files, right? So these set of files, you have this images folder, there's a 404.html, index.html, and this index.html is linked to this is a cascading style sheet, the css file. So all these things are going to be, this entire thing is going to be served by our application program. Okay, so that application program is going to be our web server. So now let us start uh, developing this, right? And I guess you would be able to do a little bit even more involved version of this. So what I'm going to do is just a basic version that at least works, and you are able to appreciate the uh, how it works, right? The basic functioning of the web server, right? So this is of course HTTP, and then we would not be, at least in this class, going to use multi-threading constructs, right? So typically the get request or the post request, or even whenever you are handling multiple clients, right, it's better to use a multi-threaded web server. So if you have done multi-threading in or p-threads, for example, in operating systems, it is highly recommended that whatever I am teaching right now, you should be able to extend those things to a multi-threaded setting. Okay, so let me start by creating the web server file. So we'll call it web server dot c. Okay, and let us start the development. I mean, it's again going to be a very simple C program that we have already studied, right? So this is a regular TCP/IP stuff that we have already studied. So let me quickly go through them, right? So at least we'll include the basic stuff. Include stdio.h. Uh, Include arpa slash inet dot h. Right. We Yeah, right now let us just stick to this, right? And on the fly we might add uh, extra things, right? So let me go to the main program, and here we will just follow the same thing that we have done earlier. So in So we are going to require these two file descriptors. If you remember, in the TCP server, this is going to be the web server, which is also going to act as a TCP server. So there is going to be a TCP server, and on top of that, we are going to run some kind of an application layer logic. So the TCP is really implemented by the kernel, right? So all we are doing is some kind of a socket API call. So this is basically my application layer code, which is going to use the underlying TCP platform that the kernel provides. Okay, so we are going to have these two kinds of sockets, which are basically your file descriptors, right? And then client socket, socket. Right, let's not worry about sockets. Okay. And then we are going to have that socket address, right? So struct sock addr in server address and client address, right? So client address, we may want to just see, right, where the client is connecting from. So if we run the browser, for instance, in my mobile phone or in a different computer, we will be able to still get their IP address, right? So if you are doing the entire thing in this computer, right, the laptop that I am kind of screen sharing, so you won't be able to get the entire story. So I'll also try to connect the server from a browser which is not this local computer, and that is going to give you a more kind of holistic feel about the kind of exercises that we are trying to do. Okay, So, and after this, I think we have to do the mundane stuff, right? So the socklen uh, underscore t, that's the ADDR address length, is equal to size of client underscore ADDR. Okay, so this is going to be required later. Okay, so the first thing that we are going to create is the server socket. So server socket is equal to socket af underscore inet. I think by now you have practiced it. So sock stream is going to represent a TCP stream. Okay, so I'm not handling the error here, but you can handle those errors where you can say that if the server socket is like a negative number, let's say -1 or something, so you can just print out an error and exit. Okay, so as I told you, I'll write the minimal code, and you are welcome to update that and add some kind of extra features. Okay, so after this, now we are going to define the server's address, right? So we have this the family, okay, which is going to be af underscore inet, and then we are going to talk about the source address. So server underscore addr dot internet address uh, source address addr. This is going to be uh, internet address any. So we are going to accept connections from any. We don't put any restrictions here. Whatever is going to be the um, address from which we are going to get the request. Okay, and the server uh, address. This is the port part. We are going to later use it for binding the socket. I think I made a mistake here. SOC. So this port is going to be a host to network, and this is short 16 bits, right? So we are going to define some kind of a macro. So so typically we would prefer to use the port 8080, right? So now what we can do, uh, so I think we have to do like define. So let us do the bind call. So bind server socket, then we have to do the server address. We have to pass the pointer, right? So this is going to be and server address, and then we have to do the size of server address, right? So this is going to be addr underscore length. Okay, or maybe we can just, because we took it as the client address, I think it doesn't matter. Size of server addr. I think this is all the same. And I think the server address we can just simply look up bind. So if you look at bind, there is this struct sock addr star, right? So we need to typecast it to this format. Just paste this. So struct sock addr star, and then and server address, and then size of this thing. So this is going to do a bind. This is a bind call. Again, I'm ignoring the error, but you are free to handle those exceptions. And after this, we have created the socket. That was the first step. Then we have added all the entries regarding the address, and then we have used the bind call, and then we are going to do a listen, right? So the server is going to listen. So listen server socket, and we have to tell the number of pending connections. Let us say 5, right? We are not really we are not going to test it out. We are going to have only one client or two clients to connect. So this is a listen call, and then after this we can basically say printf starting the web server. Okay, so server is listening on port. So what this we have created a POR. So this is just going to be the listen part, right? So after we have done the server socket definition and after followed by bind and then listen, and here we can start an infinite, for example, while loop, where I am going to accept the client connections. So that is going to be the minimal stuff we can do. So this is not going to uh, handle the client's particular request from the browser, right? But at least at the TCP level, we are going to handle this request, right? So we need to actually create a response so that the browser can parse it, because that's an HTTP request. That's what we are going to say receive in the server, and we have to process that request and send out an appropriate HTTP response back, right? Uh, we will do those things later. So first, at least let us accept the connection. Okay, so client socket is equal to accept. It is a server socket, and same thing you have to do. This is struct sock addr, and we are going to put this in the client address because we are connecting to the client, right? Client addr, and we have taken this address length, right? So this is address length, but if you look at accept, I think it takes the pointer to this thing, right? So address length is not going to work out here. We need to provide the pointer to that. So if you look at accept, uh, there is this thing we have done. Sock addr struct sock addr star. We have done this, but here this is sock length underscore t star addr length, right? So we are going to use a pointer. Okay, so we are going to use and addr length. Okay, so that should be uh, the uh, code for accepting the connection, and then I mean the connection can fail, right? So but at least let us uh, just assume that the connection works, right? And let me, for instance, we have to kind of write here some code which is going to handle the client. Okay, so that part I think we have to uh, kind of write. So one thing that we can do here is, let's say, handle client. Okay, client socket. Okay, and let us say we want to, for instance, if we want to say that to the browser that okay, this is your IP address, for example, right? So I want to send the IP address of the browser from the client's IP address from where the browser is connecting. I want to display that message, right? So maybe I want to also take the IP address, so I can figure out the IP address from here. So I can say character client IP, which is going to be the internet address length. So the standard thing to use here is this ADD RSTR ADD ADDR STR length STR length. Okay, so this is a macro that has already been defined, and then inet n2p. I think this also we have done one session in the last class, right? Af underscore inet and client underscore addr dot sin underscore addr, and here we are going to write client IP, and then this is the length of the. Okay, so we can pass this both the things, client IP as well, and we are going to handle the HTTP request in this handle client, right? Because the HTTP request is supposed to come from the browser, right? At this point, we have only kind of handled the TCP request, but we have not parsed any information, did not handle any GET request or POST request, don't know anything about the application layer syntax yet, right? So at least we can try to give a printout, say client connected, right? Say percentage S client underscore IP, and we can at least try to compile this program. Okay, there's a lot of error, so let us go through them one by one. So server ADDR is not known. Okay, so we have defined them. I think there will be a typo here, so maybe this is the issue. Let us see what are the new errors. The error is the client ADDR is undeclared. Okay, so ADDR. I think these are all typos in my typing. Server socket. So this should be in line number 18. There is the same problem in accept as well. Okay. Okay. So now if we run this web server, as you can see, starting the web server is listening on port 8080, and if we try to access this service, so we have to go to say 127 dot. So this could be one thing that we can request. So 88 is the port number, right? So let us try to request this. So nothing happens. We are not able to deliver the web page, but we don't see any response at the web server as well, because we are expecting some prints, right? I think in the last class also there was some issue with this printing, so we'll fix this, right? Okay, so I guess we are getting the client socket connected, right? I think we have to see one TCP dump to see that whether the actual exchange of the packets took place. Okay, so that is something we can definitely do, and at least appreciate the fact that whether the connection is attempted. So I'll use TCP dump. and the interface is the loopback interface. Okay, and we are going to write it to maybe web.pcap. So this is listening to that interface, and we try to connect to the server, and then we close. So there are 14 packets that were recorded. We don't know what are the packets, but yeah, I think as you can see here, uh, this is definitely the packet that our the process sent, right? So the browser sent this packet. So 38962 is the port number, right? And 8080 is basically the server's port number where it is accepting connections. So scene, CNAC, and ACK, right? So these are the three things that happened. So we did uh, get it connected to the server, right? So we have to debug simply why the printout was not happening. So I think we'll be able to resolve that. And not only that, after the connection took place, the browser also sent this HTTP GET request. Okay, so the HTTP GET request was sent to our server. As you can see, 127.0.0.1 colon 8080. So this request was indeed sent, but we did nothing to. So as you can see, the Brave and all this Chromium, right? These are basically trying to get the browser details. Okay, so these are the user agent, often it is also called. So anyway, we can see that the TCP connection was established, and the browser did send the HTTP GET request. But of course, we did nothing to send out a response. So the browser is going to be simply waiting for the response and do nothing, right? So it is going to eventually timed out, right? So we have not uh, yet seen anything at the application layer. When we send back the response to the HTTP request, then only we are going to render it in the screen. Okay, so then the browser is going to kind of say that okay, the HTTP server is responding. Okay, so if you see this 128.7.0 refuse to connect, this is actually it is trying to mention or kind of mean that it's trying to connect the HTTP server. Okay, so we did not send out the HTTP response, so that's what it means, right? But underneath, as you can see, we did establish a TCP connection. Okay, we did establish a TCP connection. See, the scene, CNAC, and ACK is there. Okay, okay. So let us try to proceed and start implementing the client. Okay, so that we can at least see whether we are making the connection successful. So at least we have gotten an evidence from the TCP dump. I think one more thing we should be able to do here is uh, let us uh, let us try to we already had a terminal. Uh, Let us try to have one more option uh, about sending the HTTP request, right? So I'll compile it fresh. Okay, so we did not have handle client. So okay, let me just comment it out for the time being, and we are going to show you one more way without the browser. So you can actually generate HTTP requests also from the terminal. Maybe you have seen commands like wget or curl curl. So wget is also fine. So whenever you are trying to request a web resource, we often use this tool called wget. So if you use wget http 127.0.0.1, and this is listening to port 8080, so I can just use 8080. So here also you can see that connecting to this thing, and it says connected, right? So the server indeed connected. right? Then the HTTP request was sent and it is awaiting the response, right? So no response was received yet. Okay, so up to this, the server must be working. Okay, and let us try to now handle the client request and at least see what request is being sent from the browser. That will also be interesting, right? So let us close this and let us go back to the code and let us try to see that what is the request that actually is coming. So I will start implementing one method called handle client. So this is handle client, and then we are going to take the client socket, which is an integer. This is just the file descriptor. So int client socket, and then we are going to use the string, which is the client IP, that is like character star client. I can just write IP, right? So it doesn't matter. And also here I can simply write that this is the like C socket, right? Just the uh, parameters that we are trying to pass. Okay. Now we have to first uh, see what bytes are being received, right? So whenever you are getting some TCP payload, we need to read the payload because we are going to respond to the HTTP request, right? So this is primarily a matter of the HTTP payload. So what we can do here is, let's say we'll take a buffer to read the data, which is the payload that is coming from the browser. So you have to define some kind of a buffer size. So I can define it as a macro. So define, let's say buffer size, buffer underscore size, how much, maybe 8192 bytes. Okay. So, uh, okay, buffer size, and then we are going to uh, read whatever bytes have been received. So there is a call, as you have seen in the previous day as well. There was a send or read, right? Like that, we also have the receive call. So we can write recv. This is the receive call, and whenever you are doubtful, you are encouraged to go and look at the man page. So if you go to man receive, so as you can see here, you can use receive from and receive message. We will stick to receive from for now. Okay, so as you can see, the type that is returned by receive is s size underscore t. So we are going to say, okay, bytes received, the number of bytes received. We are going to do the get the file descriptor, the pointer to the character buffer, the length, and the flags we can put it as 0. Okay, so again, you are encouraged to look into the details here. Okay, um, if you want to know more about it. So for now, I'll just use this receive function call, and this is going to be your the C socket followed by the buffer, right, uh, which is your pointer, and then buffer underscore size is the length of the string here. So I will use -1 to handle the extra null character. Okay, and then the 0 for the flag. So if you do this, okay, so you have to take it in some variable. So this is s size underscore t, maybe bytes received. Okay, so bytes received is equal to this. So now we should be able to show what has come, right? What has come from the browser. So let us say printf, and I want to talk about the incoming request, right? So let's say incoming request from browser. Okay, so IP %s, and then I can basically put a new line and then put the buffer contents. Okay, so I can put the client. So here this is going to be IP and buffer. Okay, so this one, let us try our luck, and we should be able to intercept the message that is coming from the at least the what is the get request, right? The get request should be we should be able to handle the get request, or not really handle, but show the content of the get request. Okay, so let us try compiling this. Again, there is a problem. Uh, so we put an extra. So let us look at line number 50. Oh, I see. Okay, so %s. Okay, so again, okay, I think this wget was, there are some pending wget requests. So I think we can put more. So as you can see, the wget keeps on trying to connect, right? So this is the incoming request from browser. Okay, and this is all the data that is being sent from the wget program, right? So if we can, instead of this, right, I can also use the browser. So maybe I'll also change the port just to make sure that things are flushed out. Let's say 8090. Okay, so 8090 is the port number that I'm going to use. So let me recompile the program. So I'm listening on 8090 port, and let us now go to the browser and put 8090. So as you can see very clearly that incoming request from browser, we have also mentioned the IP address. Okay, so get HTTP 1.1. So this is the get request, and this is all the information that is coming from the browser, right? So this is the HTTP header. As you can see, this is the HTTP header, and this is the information that is coming from as a part of the get request. So it is going to request a certain resource, and this is slash, by the way. So I think I can request some other resource. For example, I can say index.html. So this is a request I am so as you can see, get index.html, right? So we need to parse this information. So I can also say, uh, let's say some other page.html. So as you can see, the incoming request, you can get some other page.html. So this is now, as you can see, up to the application logic in the web server to serve this page, right? Serving this page is nothing but reading the page from the file system and sending those bytes to the your HTTP your browser, right? The TCP doesn't know much about it, so it's primarily a going to be a carrier of your bytes. So as long as you give the correct bytes in order, it is going to deliver those bytes to the other side. Okay, so and then the rest of this rendering and everything, right, that is going to be handled by the application layer program. In this case, this is your browser. Okay, so now I think this idea is clear that we are able to get the requests from the browser, and not only that, we are able to see the different parts of the header. Okay, so now I think our next task would be to actually intercept the message, and since it is a GET request, it could have been a POST request as well. Okay, that's what we are going to show in the eventual example. Maybe that web page that I have created, uh, that has a POST request. If you click on this submit text button, right? So this generates a post request as it was shown in the HTML content, right? The JavaScript. So you can also design your very small web page, and you can have both get requests as well as post requests. You would be able to see those requests being sent from the browser to your web server. Okay, so this is our web server. We are now at least now we can write a switch case or maybe some if conditions that if get is there in the request, we can appropriately handle that. Okay, so now let us get to that part. So now we are happy that we are able to get at least the content that is coming to us from the web server or web browser rather. So now we can write something like if say bytes underscore the received is greater than 0, this is simply a check. Okay, and here there could be three conditions, right? It could be either a get request or a post request, or it could be some kind of an invalid request. Okay, so what we can do here is let us say if so I think what we can do is we are dealing with a string, right? So uh, the we will use a string compare with get, right? So that is something that is possible. So if we do a string compare, so str ncmp buffer is where my content is, right? And then we can do get, right? So I'm trying to find out is that get is there or not in the string, and this the length is 3. Okay, and if this passes, then I can fire something that is going to process my get request, right? So I can, for now, I can say that printf get request from the browser. Okay, so handle get. If not, I mean, this is then we can see that if there is a post request from the browser or not. Let me, so at least we should be able to see that there is a get request or not. Okay, yeah, so all these things are stopped. uh, I think we have to include this, I think, to get rid of all these errors, right? String.h, that include string.h, that should be the right thing to do here, I think. Okay, so this is listening this port number 8090. Let us do this request. Okay, there is some other issue. Is it the same here? Okay, says refuse to connect, but it's the same code, we have not changed much. Okay, I think it's a small issue here. I don't know whether uh, we have not put any string, the null character explicitly, right? So what we ideally should do is that's the reason I think I took this buffer size -1 at that time, I remembered. Uh, so what we should ideally do is to put this buffer, right? So the number of bytes received, right? Because the buffer size is going to be large, right? And I don't know whether the null character is not explicitly put by the browser. So what we should do is this bytes received, this one, right, should be explicitly put as null. I think then it creates a string, and then we can use the string comparison. Okay, so hope that is the mistake. If there is something else, we have to cross check. Yeah, I think that was the problem. So yeah, I think now we can see this thing. Okay, but I think we are not getting this particular string here. So but we'll see. We have to directly, I think instead of putting so many prints here, I think the better way is to send the response and see that if the response is actually sent to the browser and the browser renders the page appropriately or not. So the next thing that we will try to do is to explicitly handle the get request, right? So instead of printing things, right, I think it's better to, there has been some problems with the printouts here. uh, Maybe it's recommended that we do it in a multi-threaded way, uh, but I think in any case, since we are doing it in a we are not using threads per se, uh, we will simply call the, instead of putting a print here, we will call a function. So we have done handle client, so I will say handle get request. So similarly, I think we can copy paste this part and say that handle post request. So instead of get, we can also have a post request. So in that case, the string comparison buffer, this is going to be compared with post. So post, post 4 characters, and we are going to do something with post. So this is the get request, handle post request. And in the post request, we are going to simply give the client socket and the buffer, right? So we can pass the client socket, so c underscore socket, and the IP, right? Or I mean the buffer, because we have now gotten the text, so we have to we can actually use the buffer. Okay, so this is something that we need to implement. uh, so that is going to serve a particular web page, okay, or at least the file. So this is a function that we need to now uh, implement. So this is going to have the socket, and then it's going to have uh, the the request basically. So I can say this is a buffer, or I can say this is your request. It is the actual term that we must use is the request, right? Is a HTTP request. Okay, so this is a function that we are going to write next. So this function is simply, what are you requesting for? We are simply requesting for a web page, right? Which is nothing but a file in the file system where the web server is mounted, right? So the web server can access in its file system whatever directory it is supposed to serve, right? That is the root directory, for instance. And in our directory, we have this file called images, and then we have this index.html, 404.html, and so on. Okay, so whenever we get this handle get request, we are eventually going to come to this code, and this code is going to handle uh, the file, right? So you basically have to uh, handle a particular file which is a resource that is being requested by the browser. Okay, so this is simply getting the file path, right? So it's going to say, if you look at the structure here, some other page.html, or it can be something like this. Let's say my files slash say photo.jpg, right? This is also something somebody can give, right? So as you can see, there is a file path, right? And this file path has to be understood by the directory on which the web server is serving on, right? So the web server is serving on a certain root directory. So here, as you can see, get my file slash photo.jpg. So this is something that is going to come. Okay, so we need to kind of take this out and see that if that particular file exists or not. If it exists, we have to read those bytes and send those bytes to the browser. Okay, back, right? That's the TCP is, we are going to write those bytes to the our underlying TCP socket, and then we are going to form something like an HTTP response, and the response is going to be, if it is well formed, it is going to be parsed by the browser, and they are going to be rendered, right? So that's not a problem. So let us develop this particular code now. as we saw, we need to get the file path. So let us try to define a buffer that stores the file path. Let's take some arbitrary length of the file path, and then we are going to see that what's the string with the get request, because we are specifically handling get request here. So we just use the scanf function, and request is our buffer that we are passing to the function, and we are going to get it like this: get and then slash percentage s. So this is what is going to be requested. Okay, and then we are going to say file path. So whatever is your um, requested resource path is going to be copied in file path. Okay, so now our job becomes very easy. So if you actually have a file in that location, you can start reading the file. So you'll just write file star fp uh, file star file pointer. Maybe I'll just write file uh, is equal to f open. You are reading the file. So file underscore path, and here let's say we can read in RV mode. So in case this is not an ASCII file and so on, right? It could be a binary file, it could be images and so on. So just use RB, okay? And you say then if file not equal to null, right? Because this could be a file that doesn't exist, right? Let's say some other .html, right? Those kind of things. We don't want to, we just want to handle those requests properly. Okay, so we want to basically, there are several things that we have to do here. So the first thing that we need to do is not only just get the content, but also there is something called the MIME type, right, which is going to tell whether it's a text file or an image file and so on. No, so those are, that's something which is called the MIME type, and I this is going to be mentioned in the HTTP header. Uh, so as you can see, whenever I'm requesting this my files photo.jpg, it also says what kind of things it's going to accept, right? So image, uh, webp, png, and so on. So those are the things that it can accept. Okay, so let us we have to kind of define the MIME type here while responding. So if it is an image, we have to say it's an image type. So these are the things we don't have to worry about too much. Here we are simply going to just follow whatever is written here. This is the gate and this is a resource name. We are really not going to look at the rest of the stuff, right? Unless and until it specifically asks us to do something, right? Which is in accordance to the service that we are providing, then all it's required. Otherwise, I don't think there is much use of this all these header fields in our particular application, right? So it only says this what kind of accept encoding and so on. So these are the things that anyway the browser does, right? So if it is being sent, if we if it is zipped, then fine. If it is not zipped, we are not using the resources optimally, but that's okay. Okay, so let us now get into the actual code of reading the file, and then also defining the MIME type and so on, right? So we will do MIME type shortly. So MIME types, so even if I show you uh, MIME types, uh, these are the common media types, right? So in the browser, when we showed you the HTTP responses and so on, there also you would also in the TCP dump, while you looked at the HTTP responses, you saw these things, right? So this is like a text. If you say text slash, so text slash CSS or text slash CSV or text slash HTML, JavaScript is also there, right? So depending on the kind of resource you are requesting, you need to mention the MIME type such that the browser is able to identify what kind of information is that and accordingly render that, right? So image BMP, right? Bitmap image. So if you say image, say slash JPG, right, or JPEG. So depending on the kind of resource that is being requested, we are going to update the MIME type. Okay. Anyway, so first we are handling the get request. So let us look at the we'll maybe do an fseek, right, and then file from the start till the sorry uh, seek end. Okay, and then we'll try to get the size of the file. We have to send out, please understand that we are trying to send out the bytes. Okay, we have to somehow read the bytes of the file and send them out, and let's say we are going to give it to our socket pipe, right, and TCP is going to handle the rest of it. So file size is equal to, let's say ftl is going to give me this file. Okay, so I'm getting the file size, and then fseek file 0 comma 6 set. Okay, so now after this I have to get the let's say get the response headers and then the MIME type, because I need to respond now. So for response I need to give a particular response header. Okay, so if you let us say even here, not here, I think in this one, let us say if we go to settings, developer tools. Okay, so let me refresh this web page. So now if I click on a specific resource, let's say this is a get request, this is a response, right? So there is a response header. Okay, if you see there's a request header and there's a response header, you can see the raw, I guess it allows you to see the raw format, but in any case, uh, this is basically the things that are there in your response. Okay, uh, so the request headers, after you get, you need to create the response header and give the response. Okay, so make sure that we have to create this thing. Okay, you have to create the response header. So typically we are going to say this is an HTTP 1.1 and 200 OK is the status code to make to convey from the web server to the browser that everything was successful, right? So if you say 200 OK, this is a green signal from the web server. If not, let's say you have to say 404, which basically means not found, or you can say something like 500. So these are these HTTP status codes, right? So HTTP status codes is something that you can look up, and so there are various kinds of status codes. So 400 to this thing is the client error response, right? So server error responses and so on, right? Successful responses is 200 to 299. We are going to use 200, which is it's successful, right? So 200 OK is the one that we are going to send. Okay. So then there are multiple kinds of requests. That's a typical request and response codes, which are a typical web server is going to handle all of them, right? So maybe we can use this 404 not found, right? Or maybe 500, right? Which is an internal server error. So these kind of things could be sent out. Okay. So let us at least try to see whether we can load the web page or not. So let us now put it in this character response header. And let us say we put just 1000 bytes here statically. This is not a very good way to write the code, but later you can refine it, make it better. Okay, and then we have to put the MIME type. So I'm just putting 50 again. This is arbitrary. So this is where I'm going to put text slash HTML or text slash JavaScript or image slash PNG and so on. Okay, so I need to tell the browser what kind of MIME type is getting loaded. So after this, I need to get the MIME type. So let us say get MIME type, because I have to again do a if else condition, right, based on the extension. So I need the file path, because the file path, if it's a .jpg or .html, that's what is going to define my MIME type. Okay, so this is what I'm going to get, and let me quickly write a small function, say MIME type. So get MIME type. So void. Uh, so I'm going to pass this information in this MIME type. This is the string pointer that I'm passing here. So get MIME type, and here I can say character star file path. Character star file path, and then we also have one more buffer, which is your MIME type. This is where we are going to write down the MIME type value. Okay, so now it's very easy. So I'll just take character star. Let's say I'm calling it an extension. So file extension, file type. Okay. Uh, just want to delimit using the character dot, right? So I'm assuming something dot html. Okay, so file path, and the delimiter here we are using is dot. Okay, so this is a very trivial, very simple thing to for demonstration, right? So actual web server doesn't the things are much more detailed, much more complicated, right? It's going to follow all uh, uh, the HTTP RFC very closely. Okay, what I'm trying to show you is more of like a not even a proof of concept for the whole HTTP, just a client server program. So just take it with a pinch of salt. I'm trying to show you a client server TCP client server communication, but integrated with something at the application layer. For instance, the browser, right? So it's a bare bones thing, but it can give you a practical idea of how things work. Okay, so you are welcome to make it more complicated or go through open source codes of simple web servers that exist, right? Okay, anyway, so if the extension is not null, let us start with HTML and so HTML, and one by one we will do it. So strcmp extension, and we are looking for .html. Okay, so this is passed, right? So this is 0. So then what do we do? We strcpy MIME type. What do I write here? Text slash HTML, right? So this is my MIME type if it is an HTML based extension. Okay, so now I can simply copy paste this and do it for other MIME types. Okay, so let's say else if the extension is a style sheet CSS, this will be text slash CSS. Now we can also have an extension for let's say JavaScript, right? So that is going to be JS, and this is going to be JavaScript. These are all important because this MIME type is required by the browser, right? You need to tell the browser what kind of content it's trying to load. Okay, so then we can deal with images. So let's say this is JPG or PNG, whatever, right? So this is going to be image slash image slash JPG, let's say. Okay, so this could be JPEG or JPG. So maybe both of them we can include here. So this or jpeg. I think both of them are allowed. uh, Image slash jpeg. As you can see, both jpeg and jpeg should be under image slash jpeg, and the in my example what I'm using are both jpeg, so let's not worry about other file like pngs and so on, at least for this example. I mean, you can keep adding things to this. Okay, so uh, well, I think this should be enough, right? So I don't want to and if you are writing some kind of custom application, so one more thing I may show you is that sometimes this is also called application. So you can have a JSON, right? For example, application can have JSON, or application can have octet stream, uh, right? uh, Octet stream is the default value. So so if there could be an unknown class and so on, and sometimes you need to deal with it particularly, right? So the browser program may be able to your JavaScript or whatever, right? That is going to understand what your octet stream means. So in that way you can handle those things. So I think this is enough here. So um, okay, so just for completeness, for this else condition, I will just treat this as application octet stream. So I can just say this as, that's the default one in any case, application, and I can write here as octet stream. Okay, so that is all. Okay, so this is about the extension, and I'm copying this extension to my I think there is some mismatch. Yeah, so this should get me the mime type in the this character pointer. We had mime type, so mime type is not now going to be populated. Now let us move to the rest of the code. So mime type should be uh, available. Okay, so now we are going to handle the uh, rest of it, right? After I get the mime type, what I'm going to do is I have to create the printout. I mean, I have to print out the response. So now I have read the file. The file is not null. I have loaded the file, and I am trying to create the character, like the response header, right? Mime type is known, right? Now I've known the mime type. Now I have to just create the response header. So now let us print the response header to the string response header, which has 1000 bytes for now. So this is going to be I have to just write, say, sprintf response header, and here I have to write this thing, http slash 1.1 200 okay, right? So I can make it in a little bit more generically, but I am not making it that generic. So I'm simply hard coding the http response, okay, and then slash n. And this is a very typical http response. You'll see this http response even from the browser. If you want to do the debug, you will see this. So content type, the content type I need to mention the mime type, that's %s, then slash n, content, some of the fields that are required, content length. Okay, so that's the long that I have taken right here. The file size is the content length. So the content length would be, let's say, %ld. Okay, and then I put a new line. Okay, so mime type and file size. So this is, now I am preparing the, I have prepared the response header. So now I can send the response header. Okay, so let's say character, so I have to put them in the buffer, buffer buffer size. Okay, um, and then now I'll try to read from the file, like I'll use fread and send, right? I'll read from the file and send the file. I'll like in a loop, right? So till I don't have anything to read. Okay. So let me initialize this variable called how much I'm trying to read, say bytes underscore read. Okay. So here I'm trying to write a loop where I'm going to continuously read from this file and going to send it out, right? So I'll write something like read and send, right? So here I'll read, so I'll use fread and I'll use here bytes read equal to fread. I'm reading from the buffer. I'm reading the buffer, and then say from one and buffer size, and from the file. Okay. Let me just make sure that the parenthesis is balanced. This has to be greater than 0. Okay. So then I am going to send out the buffer. So I'm reading into the buffer from the file, right, and sending it out. So our buffer size we have defined as this 8192 bytes. Okay, you can increase it if you want. So in send we are going to write client socket. I think we have passed client socket, so this is we have like renamed it as C socket here, right? This is a local variable. So send C socket buffer and the length of it bytes read and 0. Okay, so this is a typical file handling. Okay, and after that we can close the file. F close file. Okay, I think hopefully the parenthesis is balanced. So I think this is just a one legal call that we should be able to execute, and let us see whether it responds accordingly or not. Okay, so I think we made a lot of changes, so expect a lot of errors. What happened here? There is an else issue and there is probably some parenthesis issue. Okay, let us go back to the code. In the mime type there is an or. Okay, so this is going to be an extra thing that we have done here. Yeah, I think this should be okay. And what was the other error? So the other error was yeah, so there is other error, and then let me see whether it compiles. Yeah, I think this should be good enough. And then we start listening on 8090, and let us request index.html. Okay, what's the, so I think let me change the port and try one more time. Say 8091. So we'll just use 8091 here. So we got a request index.html http 1.1 and 8091. All these things are correct, right? So let us try to debug more whether all this mime type and all these things are handled properly. So extension is definitely not null. So those things should be correct. You can just give a print here. So I think we have entered this part, and get client request is getting called. So you can just try giving out a print and see whether it works or not. So the same thing basically. Um, okay, so we are actually getting the content type text plus HTML, content length. These things are actually correct. Okay, so where is the problem? So at least till this much we are able to parse it correctly. So content type and content length are, I'm assuming the content length is correct. Content type is also text plus HTML, so that parsing did work out. So that's not an issue. After this, let us try to see what is going on. Hopefully the buffer length is also not an issue. Yeah, at least for this example we saw it is much lesser. Uh, so file not equal to null is also like a corner case. Mhm. So definitely this is entering here, buffer and then bytes rate. Okay, I think there is a problem here, more of a syntactic problem. I think we have to use byte rate if bytes rate is equal to this, right? And then this is greater than 0. Yeah, I think this was a syntactic issue. You know, I think let me again change the port number. Uh, yeah, this looks okay to me. So let us change the port number here as well. Okay. So right now we are not getting this thing delivered here. Okay, so let me also try out from here. Okay, so there is something that is happening. It's trying to download. Okay, so I have to kind of understand what is going on here. So it's trying to download this index.html. As you can see, there is a progress and the size is 1.91K. There must be some, let me see when it completes what it says. Request sent 200, no headers. Length is unspecified. Okay. Okay. I think we made a mistake. We made a mistake here. Uh, so kind of wget told us what the problem is. Awaiting response, we started sending the data, but there are no headers, right? So it assumed something. So we created a response header. We did not send it, right? We started sending the file, right? So before sending the file, we need to send the response header. We never send the response header. We created the response header, but we did not send it out. So we need to send out the response header. Sorry for this kind of confusion. So we have to send out the response header and then follow the content, right? So client or like C socket response header right? And then what's the length of it? strlen response header. Okay, so this is something that we need to send out first, right? Followed by the actual file content. I think we should be in a better position now. uh, okay, so let us try our luck here. 8080. Now as you can see, something is happening, right? So at least this is trying to load this web page. The page is not getting loaded, but at least it is trying to load this web page. At least the, as you can see, computer networks, OBS course test page, right? So it has started. Okay, we will see. There might be some other issues in the rest of the code that has to be fixed. Okay, so let us also see here. It use this index.html we requested, and then the browser downloaded this index.html, and then automatically requested images name.jpg, right? Because that was a part of the HTML web page, right? This name.jpg. So those things are working. So the browser immediately asks for this resource, right? We need to see whether we are sending it correctly or not, right? So let us see what happens with our wget. So the wget is this, right? So I'm trying to get this web page. I should not be using wget in the same directory. So this is kind of dangerous. I'm removing this. So I am using wget here, right? So as you can see, uh, connected, HTTP request sent, awaiting response 200. Okay. So the length is this, saving to index.html and so on. So you are able to download something from the web browser. The speed is very high because this is the same computer. Okay, but we need to see what is going on with the browser. uh, so the browser somehow is not. So let us see developer tools. Well, let's say reload the page. So it does load this index.html, name.jpg. This is a response. Okay, uh, I guess you can also see the preview. Yeah, the preview is correct. Headers. So there is no response for the style. Okay, so it may be an issue. The style.css is not probably getting loaded, and that is basically causing the issue. It's not really letting the page load. Okay, so style.css. So do we have an entry, right? We have an entry for this. So this should work. We have text slash css. So this should work. Uh, so if we do not have the style sheet, let us say if we do not have the style sheet in the web page, whether it would work or not. So I'm editing the index.html itself, right? And let me refresh the web browser. Yeah. So as you can see, this content does come, right? But yeah, style.css, it is no longer requested. I have not put this resource anymore in the web page, right? So as you can see, this simple web page is downloaded. Okay, But what is not getting downloaded are the other components, which are the image. You would be able to show the image and as well as a style sheet, right? So those are the things that we have not handled yet. So anyway, we'll figure it out. So we'll try having the full path, but at least even without this, we should be able to load the image. Okay. So now let us go back to our web server code and see what is going on. The image is definitely JPG, so we should respond with the MIME type image/JPG. So I don't see any apparent issue with this, right? Maybe the size of the style sheet is, yeah, these are all within the limits, right? So this is 2 KB, this is 1.2 KB, and the image is, oh, the image is pretty large, right? So both the images are pretty large. Okay, so this buffer size is not going to suffice. So maybe we'll make it into 10. Okay, and then try it out one more time. Okay, still the same problem. So I put a closed socket here. Uh, so here, if you look at handle client, so we are trying to handle the get request, right? And then we are ideally we have not requested. I have not created a post request yet, right? So the close client, right? We are basically closing the client socket. I don't think that matters here because we were able to load the HTML page, but we were not able to fetch the image or the style sheet, right? So there must be something wrong with that part, right? So the way we are handling the get request, right? So let us give it one more try. Uh, and see. Let us say, I think this works for now. Or no, this will be some cached content. Okay, so it's the same phase. I think what we need to show is, let us go to a random web page and then see. I think we are missing out something in terms of uh, the header. So if we look at the elements that are being downloaded or whatever, right? So let us say uh, review, response, and so on. If we look at the raw response headers, mm, we have not done anything incorrect. We have done this content length we have sent, content type we have sent, right? And uh, that should be it, right? So we have not really made any mistake there. But if we get into, let us say, if we just take a TCP dump, or I think we have parsed these files earlier. I think as a part of our previous socket, not socket, we actually HTTP parser, right? So I think if we look into the Yeah, so if you look at the HTTP text, I think this is where we are making a mistake. This is going to look into the delimiter, which is /r/n/r/n. So this is what is going to be the ending part of your request as the response header. So I think this is where we made a mistake, I guess, because if we look at the response header, what we are sending is HTTP 1.1 200. Okay, this is all fine. Content type fine. Content length, this is incorrect, because what the HTTP protocol needs is /r/n/r/n. Okay, so this is something that is a part of the HTTP protocol, and we need to follow this to make sure that we have the proper segregation of the response header and the response payload, right? The content that we are trying to send out. So let me try this and see whether there is any improvement. So we are at 8090. Yeah, so I think that got better. So I think that was the problem. Okay, so we were not able to send the response header properly. So the response was not being parsed by the browser properly, right? So it did not, although it sent out the request, it was not able to render because it got confused, I think, in between the response header versus the actual payload that is going to come, right? So now I think if we change this thing, right, we had the style sheet commented out, so we will uncomment the style sheet and then uh, refresh, right, because we don't need a change in the browser code. Yeah, so now as you can see, we got the full web page rendered. Okay, so this is from my local host. So what we can also do is, let me see what is the uh, IP address. This is 192.168.110. So I can also use this IP address, and I can also access this web page from other devices. For example, my mobile phone. I will not be able to show you the recording, but at least you can. I can show you what the where the request is coming from and all those things. Okay, so it does not allow 192 or this. What is going on? Okay, so the web server is not running itself. What is the port number? Maybe I can change this port and give it a try. So index.html, there is no issue anymore. HTTP parser is not needed. And let us try out 8080, the good old HTTP port. There seems to be an issue. This should not be the case. We have used, yeah, this should not be the case. Let us see what's the problem. But at least we are able to load it in the local network, in the local host. But we should also be able to load it in the LAN, right? So any client which is in the same LAN should be also able to load this web page. Okay, so let us debug that particular issue, and then I think we should be in a fairly good position to uh, test out more features. Okay. Okay. So as you can see, the incoming request is coming from browser 192.168.0.110. Okay. So now what I'll do, I'll try to use my mobile phone in and try to load the same web page, right? So I have to mention, I have to go to a browser. Okay, so let me go to I have a I also have a Brave browser in my mobile phone, and let me try to browse to 192.168.0.110 colon 8080 slash index.html. Let me request this resource, and as you can see, you cannot see. I am able to see the web page loaded in my mobile phone, and you can track the IP of my mobile phone, right? And also you can see this is an Android. Uh, yeah, so this is 192.168.0.102. Okay, and this is again the agent is Linux and Android 10K, right? So these are the information that at least you can get from here. Okay, and whereas in case of earlier request, it was, as you can see, this was a Linux x86-64 which referred to my own laptop. Okay, so I can do one more. I have one more system which is a desktop system, and then I think for fun we can try out to load the page there as well and see what happens. 192.168.0.110 colon 8080 slash index dot html. Okay, so this is 108. My mobile phone was 102. The other system is 108, and this laptop is 110. Okay, so here also, as you can see, this is Linux x86-64. Okay, so some of the details might be different. This is Chrome 139, Safari 537, something. Okay, which is probably different uh, from the from the laptop, right? So this is Chrome 139. I think it's the same thing. Okay, but in general, what you saw now is that I am able to intercept uh, requests coming from browsers from any hosts that reside inside the wireless LAN, right, and serve them the web pages. Okay, so this is a minimal code that is able to host your website. Okay, and if I put some other image or more images or make the HTML page more complicated, then also it should work. Okay, then also it should work, right? So what I have not done yet is uh, trying to create some response for the post request, right? So some of it I think I would recommend you to complete on your own. uh, but what I intended to do was this, right? So let's say this is a lecture on socket programming. Okay, so if I write this and say submit text, I expect some reply, right? So this request goes to the server, right? As you can see here, there was an incoming request, and this request from the browser, from the client, was this, right? This is a lecture on socket programming. Okay, and I have defined this delimiter. If you remember, this percentage sign, star star percentage sign, and same here. This is my own delimiter to kind of define my message, right? So that I can easily parse this message, right? Of course, there is a part of the protocol that defines various other things, but I think just to be under my self control, right? I can define my message within this delimiter, and of course, this delimiter cannot be a part of the message that goes without saying, but I can do some basic operation, right? Let's say you want to count the number of characters, or any kind of APIs you want to provide on this string, you can provide it from the server, right? So this is a post message also. Please see here, this is post HTTP 1.1. So you need to have one more function in the code, that instead of handling the get request, you have to handle the post request. Okay, so you need to handle the post request. For that, you need to for your, like, you have a specific kind of a response that you want to give as a part of the post request. So that I think I would leave it up to you. Okay, so I'll definitely implement a small function. Let's say void handle post request, and then I have to give again the same thing, c socket and character star request. So this request is now a post request. Earlier it was a get request. Okay, and here I think if you want to do something with the request, you are welcome to do that, right? So whatever response you want to send, you can send, right? So I would not really get into it. So I'll write do your own processing on the request to generate the response. Okay, so you may have multiple different functionalities, and you may have in your web page, you may have various buttons, and each of the button might trigger a different kind of a post request, right? And your server is basically going to handle these jobs, right? So it is going to necessarily be a backend, right? Or this could be connected to a database where whatever information is being entered through the client browser system is going to be sent out as a post request or a get request to this web server, and the web server can delegate this thing to a backend database, or if it is doing some kind of processing, it can do those kind of processing as well, right? So I am not really telling you what exactly to do, so you can do this on your own. And what you really need to do is that you need to send out a response, right? Similarly, I think we made a small mistake in case of the get request. Same for the post request, you need to make sure that you are sending out a well formed reply. Okay, so I mean, you can define a response body. So let me say this is a response body, and let's say this is some 1,000 characters, right, or 10,000 characters, and then is printf response body, and followed by http slash 1.1 200. Okay, this is a necessary part, slash n content type. I would just go for text slash html slash n uh, and then I think I can just simply mention the uh, I think what we need to do here is that /r/n and then give the message, right? So I can basically write any HTML content, and that content is going to be the response body. Okay, so say I want to say uh, let's say some p received message, something like this. I think we still need to give the proper HTML tagging, right? So we need to probably give the HTML head, body, and so on. But I'm just uh, trying to see if this works out. Okay, and after this, you need to send it out. So send C socket and response body. So this is another mistake we did last time. We were not sending it out. So we have to send it out and then strlen string length of response body. So once we do this, we should be done. So this is a post request. We are really not doing anything, but this is something that you can fill it up, right? You can write your own function calls and do any kind of processing that you want. Okay, so let us recompile this. Okay, so submit the text. Yeah, I think it doesn't do anything. We can at least see if there is any response that is being sent. To go to the developer tools. Okay, yeah, we were not able to send out a response here. So what if we so there must be a problem. So I think we are following the same code. C socket response header, length of the response header and 0. So it's the same thing here. Send C socket response body string length of response body and 0. Okay, uh, and here we have included the header, so that should not be an issue. Mhm. So what is going on, I think, is uh, the response. Okay, I think we made a major mistake. We have never called this function. I think I wrote the sketch for the function, but we never called it. Right. So I think this is the mistake. Okay. Now uh, let us have something like this. So there is some response, right? So the response we said is text plus HTML, right? And that was the request. Okay, the payload is this. The response we did receive. Okay, here also we are able to show. right? The received message is whatever we sent, right? I did not make any special uh, considerations there, right? It's a simple thing. So I can try this out from my other browser as well, right? So I'll try out my mobile phone's browser and put a code there. Hello. So this is where I'm loading now. This is 102. This is my Android system. So I'll try to write something here. Hello from my smartphone. Okay. So here, as you can see, hello from my smartphone. Okay, and I got this response in 100 plus milliseconds. This is 167 milliseconds. Okay, so now if you have many devices, the response time is going to shoot up, right? And that is the reason you need a multi-threaded server where this handling the client, right, has to be done using a new thread, right? So whenever there is a new uh, client that comes, right, this handling the client, you should, instead of doing this, you should be using the typical function pointer way, and using p threads you should be doing it. Okay, not the way that I have shown here. This is a minimum functional thing that as long as the socket programming and network programming is concerned, whatever concepts are being taught or had been taught was kind of conveyed by these programs. But to make it more professional, you should ideally use or implement this web server in a multi-threaded way. Okay, so I guess you have already studied p-threads. So instead of using this handle client in this non-threaded way, you should have it in a, you should implement it in a threaded way, right? You, and then you have to link like p threads and so on. So while you compile, you do this minus lp thread, right? So my suggestion to all of you, whoever is kind of diligently following these tutorials, you should be first of all implement something on your own, right? So try to implement some kind of a post response, right? And you can make it more interesting. For example, you can I can give you an image through the post request, or right, through a post request, for instance, and you can invert that image and then give it back to me, right? So I can simply upload an image, and I can submit the click but like a submit button, right? And once I click on the submit button, the server should invert that image, send it back to me, and I should be able to display that in my browser page, right? So this much you should be able to handle here. So you can write more fun stuff here. Okay, so I am going to tell you, uh, please write some more fun programs, and this will be really nice, right? So this is a web server, so it's not necessary that you are going to use the same local host for um, uh, connecting to the web server. You could use any smartphone or a laptop, right? Extra laptop, right? If you have, which is connected to the same Wi-Fi network, and you should be able to access the web page. Okay, so it's a very nice kind of inspiring exercise for you, I guess, and hopefully you'll be able to replicate this thing, right? The next thing that you should try to do, apart from modifying the post request, is try to do this in a threaded way. So I did not use threads. Please try incorporating p threads. Okay, so you can and then you can try to have many clients which can try to connect to your web server, and you can see that your latency is going to increase slowly. Okay, so hopefully you got some idea about socket programming, as well as using this TCP dump tool, right? So in addition to whatever theoretical concepts that you have learned, some amount of network programming would be good. So I showed you some amount of network programming, and that is going to be kind of completing our course. Okay, so hopefully you would have a good learning experience, and wish you all the best for your final exams.